Hi friends, in this video I will explain data link control service in detail for 8 marks. So first we need to list out which and all the data link services are present. So data link services which will be containing a framing, flow control and error control. So the data link control deals with the procedure for communication between two adjacent nodes, which means node to node communication. So these which will be control functions which will including framing, flow control and error control. So in the framing we will be having the in detail concept about the bit oriented and character oriented concepts. First service is that framing. Data transmission in the physical layer means moving a bits in the form of signal from the source to the destination. As we are know that in the network we will be sending the data from sender to the receiver. It has been passed on to the OSI layer, and then here we are going to concentration with respect to the data link layer only, because this data link control services are maybe the detection and then correction it has been takes place in the data link layer. The physical layers provides a bit synchronization to ensure that sender and receives use the same bit duration timing. The data link layer on the other hand needs to pack bits into frames so that each frame is distinguishable from another. We have sent a data from sender to the receiver. So from data link layer to the physical layer, it is converting frames into the bits, and then based upon your data, the number of frames or maybe it will be divided. So framing is in the data link layer separates a message from one source to the destination or from other message to other destination by adding a sender address and destination address. The destination address defines where the packet is to go, and the sender address helps to the recipient across the receipt. So the sender is responsible for sending a message or maybe frames. Whatever the data he has sent from a sender, you need to get the acknowledgement. So from the receiver it should receive a acknowledgement which is going to ACK signal. So frame can be fixed or variable size. Within the fixed size framing, in the fixed size framing, there is no need to defining the boundaries of the frames. In this, it is fixed. Out of that, we can use a minimal amount of the size or maybe space or maybe maximum amount of the space. There is no boundaries are present. The size itself can use as a delimiter. Variable size framing. In this variable size framing, we need a way to define the end of a frame and beginning of a next. We need to mention where it is starting and then where it is ending. So for that we require some the delimiter. Historically, two approaches were used to this purpose: character-oriented approach and bit-oriented approach. These are the two approaches are present under the variable size framing. So first we will discuss character-oriented protocols. In the character-oriented protocols, the data to be carried out are 8-bit characters from a coding system such as ASCII. So each and individual characters and the numbers it will be represented by means of ASCII standard. The header, which normally carries the source and then destination address and other control information, and the trailer, which carries the error detection or error correction redundant bits, are also multiples of 8 bits. So in addition to the data, there are other the contents or components are present: header, trailer, or maybe other fields. To separate one frame from the next, the 8-bit flag is added at the beginning and the end of a frame. To indicate that one 8-bit flag it has been added in the beginning as well as the ending. So at the time it will come to know that the frame it is starting from which position and then ending at which position. The flag composite of protocol dependent special characters signals the start or maybe end of a frame. Yes, if you observe here, this flag it is going to indicating starting, and then another after the trailer it is going to ending of a trailer which is going to indicating ending of a frame. So data from upper layers variables number of characters, out of that which will be having the header row and then other content it has been present. So flag should be different from the text pattern used in the data section. Otherwise, when the receiver encounters this pattern in the middle of the data, it thinks that it has reached the end of a frame. So because during transmission they may chance of what this the flag pattern can insert in between the frame. So at the time the it will be confused that in the middle of the content itself if we encounter this the flag which will identify as a end of a flag, end of a frame. So here to fix this problem a byte stuffing strategy was added to character oriented framing. So then we need to discuss the byte stuffing is the process of adding one extra byte where there is a flag or escape character in the text. So to solve this problem we are going to adding a extra bit, right, whenever there is a the escape or maybe the flag bits are present. The data section is stuffed with the extra byte. This byte is usually called as the escape character, shortly known as ESC, which has predefined bit pattern. Wherever the receiver encounters the escape character, it removes it from a data section and treats the next character as a data, not as a delimiting flag. If even the escape character is also part of text, an extra escape character is added to show that second one is a part of the text. So this is the what original data we need to send from a sender to the receiver, right? So whenever we have encounter onto the flag or when we escape, we will be adding a one extra bit, that is we are going to call it as what ESC or maybe escape character it has been added. So that process of performing this one will be called as what stuffing, bit stuffing. So here we are going to indicating flag it is a starting and then this is ending. In between that if any this type of by the network or maybe data itself if we encounter this pattern we need to add this escape. So here this is the data are present and then will be the escape character it has been byte it has been added and then here escape it has been present we have added. So the process of performing this will call it as what byte stuffing. This the whole content it has been passed in the transmission medium and then it will receive the receiver. So in the receiver frame it has been received, it will check whether the extra bits are present. If this pattern it has been encountered, then it is going to remove or unstuffing. The process of removing an escape character from a received frame, that process we are going to call it as unstuffing. So and then original data it has been delivered to the corresponding receiver. Character-oriented protocols present another problem in data communication. The universal coding system in use today, such as Unicode, have 16-bit or 32-bit characters that conflict with the 8-bit characters. So next, bit-oriented protocols. In a bit-oriented protocols, the data section of a frame is a sequence of bits to be interpreted by the upper layer as a text and graphic, audio, video, and so on. In addition to the header, a special 8-bit pattern flag 0 followed by 6 ones is used as a delimiter to define the beginning and end of a frame. Whenever this type of pattern has been occurring at the time which is going to indicating beginning and then ending of a frame. So this is the pattern it has been present, and then if the flag pattern appears in the data, bit stuffing is used to differentiate the flag from a information. Again, in case if we are having this pattern in the data also it has been encountered, then it is going to indicating that this is the end of a frame. So to avoid that one, we are going to making the simple as possible. So to identify the starting and then ending, so by making use of what some patterns. So that pattern which may having the out 0 followed by the 5 ones. If the flag pattern appears in the data, bit stuffing is used to differentiate the flag from information. So bit stuffing is the process of adding one extra 0 whenever 5 consecutive ones followed a 0 in the data. So just now I told that within the data if any pattern it has been occurring, 0 pat followed by a 5 ones it has been present, we need to add extra 0. So that receiver does not mistake that pattern 0, 5 1 0 for a flag. To perform that one, we can have the pictorial representation here. The extra stuff bit eventually removed from a data by the receiver. So this is the data I will be sending to the receiver. Within this, they may chance of having the 0 followed by a 5 1 0 pattern also it has been existing. Right. So as an assumption of this, whenever we are going to encountering a 0 followed by a 5 1s are present, we need to add 1 0. So here the data bit after the 1, 2, 3, 4, 5, we are going to adding a 1 extra 0, right? And then similarly again one more time we are going to presenting a pattern 1, 2, 3, 4, 5. We are going to adding an extra 0. The process of adding zeros with the corresponding rules and regulation, the process we are going to call as what? The stuffing. And then so with respect to this. So with respect to this, again this frame it has been received, right? So and then here the whatever the extra bit has been added, which has been removed, right? Whenever this pattern has been encountered, 0 it has been unstuffed, and then 0 it has been unstuffed, and then final data it has been received to the receiver. So these are the things we need to explain with respect to the bit oriented and then character oriented approaches. So next the service it is the flow control. So flow control coordinates the amount of data that can be sent before receiving an acknowledgement. So flow control refers to a set of procedures used to restrict the amount of data that can send before waiting for acknowledgement. So we already know that if the flow control is not monitored properly in the network, then definitely the congestion has to be happening. The flow of the data must not be allowed to overwhelm the receiver. Any receiving device has a limited speed at which it can process incoming data and a limited amount of memory in which to store the incoming data. Each and individual devices are maybe the networking components which will be having the buffers. The receiving device must be able to inform the sending device before those limits are reached and also request the transmitting devices send a fewer message or stop temporarily. So incoming data must be checked and processed before they can be used. The rate of such processing is often slower than the data of transmission. For this reason, each receiving device has a block of memory called buffer, reserved for storing incoming data until they are processed. So next, the last service is that flow control. Error control is error detecting and error correcting. It allows the receiver to inform the sender any frame lost or maybe damaged in transmission and coordinates the retransmission of those frames by a sender. In the data link layer, the term error control refers primarily to method of error detection and retransmission. Error control in the data link layer is based on the automatic repeat request, which is the retransmission of data. Thank you.